Another package that is available for analysis is global fitting. This involves fitting multiple data sets to the same model, or even to different models where some of the parameters are common between the data sets. The first step in doing this is first to fit each of the individual data sets to give good starting guesses for the different models. For this, I want to use two data sets, latex particles measured in both the SANS range and the USANS range. I don't have these graphs open anymore, but I've already loaded the data. If I want to plot both of these data sets, I can use the plot manager. These data sets are in memory, so I can plot the latex set, select it, and choose a new graph, and then the USANS slit smeared data, and append that to the graph. Now that I have both data sets on the same graph, I can plot smeared models that are appropriate to both of these data sets on the same graph. An appropriate model that we can load in is one of spheres with a Gaussian distribution of sizes. If we start with the SANS data set, we can plot that smeared Gauss spheres and append it to the graph. We can do the same for the USANS data set. This will plot it with its own resolution, its slit smeared resolution, and we can append that data set as well. To avoid confusion, we can color one of the traces black. We'll start by analyzing the USANS data set individually, since it is much more feature-rich. Clearly the radius needs to be larger, since the oscillations, the fringes in the data set, occur at a very low Q value. The polydispersity also appears to be a bit large, since the fringes are not very visible. For this example, I do not know what the sphere or the solvent scattering length densities are. So in fact, I'll just hold these fixed and let the volume fraction, which is essentially a scale factor, vary. Also, I do know that the background should be rather low. If I do the fit, it is very fast now. This is because the USANS slit smearing is done using a matrix method, which is much faster than the previous method, which relied on a numerical integration to converge at each interval. I can take these numbers of a radius of about 2300 and a polydispersity of 0.037 and apply that to the latex data set. In addition, the volume fraction, as we found from the latex set, was about 0.05. Again, if I switch to the SANS data set, I see the SANS data set coefficients. And you see a pretty reasonable match once we add in an appropriate background. So these values would provide very good initial guesses to global fitting. For global fitting of data, the package is selected by choosing it from the SANS Models Packages menu, Global Fitting. This panel is different than has been used previously for global fitting. This uses a wave metric supplied panel, which is much more powerful than the previous version. As a result, it is somewhat more complex. I have tried to hide unneeded features to make the selection a bit simpler. The first thing to do is to add data sets from the top graph. This adds our latex, SANS, and USANS data plus the fitted models to our data, which we don't actually want to fit again. We can remove these smeared models from the fitted list and the fitted Y-wave. This leaves us with two data sets that we want to fit. And the next step is select one of the models, select one of the data sets, and choose the fit function, which in this case we want to be smeared Gauss spheres. Do the same for the other function. This has 6 coefficients in the parameter list. We enter 6, and it automatically fills in 6 coefficients everywhere that function appears. With this version of the global analysis panel, different functions can be chosen for different data sets. You're no longer restricted to fit the same model to all of the data sets. The next step is to decide which parameters are linked, that is, which parameters are common between the data sets. The obvious choices are the second parameter in the list, which is K1, since the numbering starts from 0. This would in fact be the radius. Select both of them and link them. The polydispersity should be the same, the second parameter. Link it. Similarly, the scattering length densities should be the same, so those should be linked as well. I am leaving the volume fraction unlinked, since in case there are slight variations in the absolute scaling of the USANS and SANS data, this can be corrected for by adjusting this volume fraction, which is essentially a scale factor, since we do not know the scattering length densities in the system. I have also not linked the backgrounds in each of them, since they will be different. The next step, since the data sets and functions and linking has been set, is to choose the coefficients. These are our initial guesses for the data sets. Again, the numbering starts from 0 through 5 for the 6 parameters. The first data coefficients that it would like you to enter are for the SANS data set. So we have initial guesses of 0.055. I'm typing these directly from the fits that we just used, and they need to be reasonably close. They don't have to be perfect. The last one on the list here, you'll note, is for the USANS data set. This is the volume fraction value for the USANS set. We'll start that initially as the same as the SANS set. The final coefficient to enter is the background for the latex USANS set. We'll set that at 0 and hold that fixed. The other parameters that we want to hold fixed are the scattering length densities. Everything else we would like to leave free and linked. That would be the radius and polydispersity. The final thing that is necessary to set is the weighting of the data. This is done automatically from the CurveFit setup panel when you're fitting 1D data sets. It knows what weights to use. For this, you need to select it. Click on the checkbox, and you're presented with a panel where you have the 2 data sets that will be fit and allow you to select the weighting wave. All you have to do is click in the grayed out box. It will automatically find the standard deviation of the intensity wave based on what the data set is named. Click both of those and select Done. In the same way as the original Global Fit panel was set up, you can mask data sets by using cursors on the graph or apply constraints to the data in a linear programming sense. Since these have been set up, The data sets and functions have been set up. The input coefficients for the initial guess have been set up. We can actually do the fit to the data in a global sense. Fitting USANS and SANS data this way, again, will be much faster than it was previously, since the smearing for the USANS data set is now done in a matrix method. In addition, all the curve fitting will be faster, since the fit functions have been ported to compiled C code, which is a factor of typically about 7 faster. A report is automatically generated as before, showing the fitted parameters, the chi-squared value, which parameters were held during the fitting, which parameters were linked, and to which data set and coefficient they were linked to. The fit is good. It's very good in this case, and we're happy with this and don't need to run this again.